Hi guys, Mr. Bullock here, and this is Board Problem 29. A member of Congress wants to know what her constituents think of a proposed legislation on health insurance. Her staff reports that 228 letters have been received on the subject, of which 193 oppose legislation. What is the population of this situation? The constituents, the 228 letters received, the 193 opposing the legislation, Congress, and none of the above. My principal said I'm going a little too fast in these videos, but I don't want to keep them long, so you guys can pause wherever it's appropriate, okay? So you're probably pausing a lot on this, but answer this, the population is her constituents on this, so it'd be choice A. Okay, simulating experiments, and this lesson is going to allow us to use Table B and other methods to simulate experiments that would otherwise be tedious or not probable. So here's a girl in the family. And we're going to do a couple examples off this. What is the likelihood of having a girl among the first 4 children? Okay, and this is example 520 on page 309. Suppose we are interested in estimating the likelihood of a couple's having a girl among their first 4 children. Okay, so they're only going to have 4 children, so what's the likelihood that this one's going to be a girl, at least? So let a flip of a fair coin represent at birth, the birth, and with heads corresponding to the girl and tails corresponding to the boy. And since the boys and girls are equally likely to occur, and the coin is equally likely to occur, then flipping a coin would do a nice simulation of this experiment right here. So the appearance of, so flip the coin until the head appears or until the coin has been flipped 4 times, because they're either going to have one girl until a head appears, and they're going to, or 4. So they're either going to have 4 boys or they're going to get a girl amongst their 4 children right there. That's our question. So the appearance of a head with the first 4 flips corresponds to the couples having a girl amongst their first 4 children. If this coin flipping procedure is repeated many times, not because they're going to have sets of 4 kids, but we can simulate this, you guys, and find the probability to represent the births in a large number of families in the proportion of times that a heads appears with the first 4 flips would be a good estimate of the true likelihood of the couples having a girl. Okay, so here's number 2. A couple plans to have children until they have a girl or until they have 4 children. So here, if they get a girl first and they stop, I don't know what their goal is on the girl, although that's cool, but so it's just kind of, never mind. So what's the likelihood they will have a girl? All right, so here we go. In the prior example, we used a coin to simulate this, but I'm going to show you how to use Table B on this as well, you guys, so to simulate this. Now, so the rest of it is explained on example 524 on page 313. So on Table B, we're going to have one digit simulate the sex of a kid. So of the digits 0 through 9, that's 10 digits. So 50-50, if I did the first 5 digits, 0 through 4, to be a girl, and the second 5 digits to be a boy. So to simulate one repetition of the childbearing strategy, we read the digits from Table B until the couple has either a girl or 4 kids. Okay, so notice that the number of digits needed to simulate one repetition depends on how quickly the couple gets a girl. So because they're either going to get a girl or have 4 kids, 4 boys. So here's the simulation, and we're going to start at line 130. So go ahead and pause right now, you guys, and open your books to the back to Table B. I want you to be able to locate this stuff for me. Okay, go to line 130 and interpret the digits. Okay, G would be girl, B would be boy, and we're going to write those underneath those, and then we're going to put plus signs indicating if a girl was born or a minus sign indicating that it was not born. Okay, so here's line 130, you guys. So the first 3 digits, the 2 numbers were boy, boy, and then this one was a girl, so they stopped. So then we started up with the next digit, 5 and 1, so it went boy and then girl, and then we stopped. And it went boy and girl, and then boy and girl, and boy, boy, and boy and girl. There's 4 kids finally. They didn't finally get 4 boys until the 14th time, you guys. So what happens here is the estimated probability is 13 out of 14 times, which is about 93%. Okay, so, and I'll show you later how to get the mathematics of this later, you guys, but the true number on the probability ends up being about 0.938, so we got pretty close just with this one simulation in the back of the book. Okay, so let's try something else here. So we're going to toss a coin 10 times. What's the likelihood of a run of at least 3 consecutive heads or 3 consecutive tails? And we're going to toss it 10 times. So So here we go. We're going to use example 521 on page 310 and 311. So a head or tail is equally likely to occur. So tosses are independent of each other, and so is that back of the book, you guys. That back is totally independent. Each digit are randomly digits. So table B, so we're going to use the digits 0 through 9, which is 10 digits, you guys. And so each digit has equal chances on that to occur, 1/10. So one digit simulates a toss of the coin. And we'll just represent the odd digits. Oops, let me go back. The odd digits to represent heads, and all the even digits are going to represent tails. Okay, so we want a run of 3 heads or a run of 3 tails. So look at 10 consecutive digits in table B on one repetition. So read many groups of 10 digits from table B to simulate this repetition. Okay, so here's the first 3 repetitions starting at line 101. Okay, so a run of 3 or more heads or tails are going to be underlined on this. Okay, so there's the first 3 digits right there. Let's see if I can separate them right here. So let's see, 5, 10. So there's the first run of 10 right there. There's the second run of 10, and so on. Okay, so what I'm going to do, remember, the odds are the heads and the tails are the evens. Okay, so I just did the first 10 right here. Heads, heads, tails, tails, heads, heads, heads. And it got underlined because we got 3 heads in a row. And then I'm going to do the rest of them right here. Okay, and this is just the first 3. And notice we got 3 heads and or 3 tails in each group of 10 numbers right there. So run a 3, yes, yes, yes. So it asked us to do this 25 times. So that was 3 times right there, 3 groups of 10 right there. So we did. So if we did it 23 more times, and 22 additional repetitions were done, and 23 of them had a run of. So that meant 3 of them didn't have, or 2 of them didn't have a run of that. So the estimated probability of getting a run of 3 heads or 3 tails is about 92%. That was on our simulated chance right there. Okay. And of course, 25 repetitions are not enough to be totally confident, but it did give us pretty good representation of our estimate accurate. Now that we understand how to do the simulation, we can tell a computer to do it many thousands of times. Actually, your TI calculators will do it also. I'll show you that later after break. A long simulation or mathematical analysis, and I'll show you how to do the mathematical analysis later. So they got about 82.6. So wasn't as close as last time, but pretty close. Okay, here's section D, and this is going to be assigning some digits. So from here, I'm just going to show you how to use table B to assign digits. Some more examples here. Okay, so this is letter A. Sorry, my A got squished away over there. Choose a person at random from a group of 70% who are employed. One digit simulates this. So in the back of the book, since I have 70%, I can have 70% employed. These guys, all these digits could represent my employed guys, and these guys could represent my unemployed guys. And this would be 70%, and this would be 30%. Okay, that's a good way to represent 70-30. You could also represent them by 2-digit numbers, 0001 all the way up to 69, and then 70 all the way up to 99. But that way is just not as it's slower way to do that right there. So it's less efficient. So it just takes a little longer to do it that way. So it's 70%. I'd do it this way right here, the first way up here. Okay, all right. Here's another one. Choose one person at random from a group of 73%. Okay, this time I have to use 2-digit numbers. So I would choose 00 up to 72 because that's 73 numbers, and then these guys would be the not employed right here. That would be the other 27%. Okay, so we assign 73 of the 100 2-digit numbers to be employed, and the other ones, and you could also do 01 up to 73%, you guys. That would work just fine as well. Okay. So choose one person at random from a group of which 50% are employed, 20% are unemployed, and 30% are not in the labor force. Okay, so since these are all nice cutoffs, you guys, 50, 20, and 30, I can use 1 digits, you guys. Here's 5 numbers that would represent 50%. Here's 2 numbers that would represent 20%, and this would be my 30%. Okay. Another valid assignment might be something like this. You can do, you just flip them upside down. Okay, if that makes sense, you guys. All right, and so what's important is the number of digits they assign to each outcome. Okay, so to represent the correct percentages. And then I think we're going to wrap it up with this one here, you guys. Frozen yogurts. That kind of sounds good right now. I like frozen yogurts. See example 523 on page 312. I wish we can just go experiment this at the yogurt shop, huh? Yeah, yeah. Orders of frozen yogurt flavors based on sales have the following relative frequencies. 38% are chocolate, 42% are vanilla, and 20% are strawberry. So the experiment consists of customers entering the store and ordering yogurt. The task is to simulate 10 frozen yogurt sales based on the recent history. Okay, 10. So instead of considering the random number table to be made of single digits, we're now going to be considering to make up pairs of digits. And the only reason is because that's a 38. It's not a nice round 30, and that's a 42, not a 40, you guys. So we're going to do pairs of digits on this. It's because the relative frequencies have a maximum of 2 digits on that. Okay, so here we go. So what I'm going to do is 00 to 37. That's going to be my 38% for chocolate. And then this is going to be for my vanilla, 38 to 79. Oh, there's another announcement. Sorry. I knew I couldn't get through lunch without an announcement here. This school's classic with announcements. Anyway, so that's how you'd represent the chocolate, vanilla, and strawberry on that. So the sequence of random numbers starting at the 21st to, okay, now go to row 112, you guys, on table B, and then go to the 21st column, which is the 21st number in there, and that's where we start. So make sure you can locate that. It's kind of in the middle of the page, these numbers right here. I don't know why they went to that, you guys. They just want to be random. They just went to that little piece right there. So locate these numbers, the 21st row, or 21st column of the 112th row. Okay, and so it yields these 2-digit numbers. 19 is right there, then 35, and then it goes 27, and then 30, and then 89, and so on, okay? And so all of those numbers represent all of these guys, so they just fall into chocolate, vanilla, or strawberry, okay? So I just brought that back up there. There it is right there. So they come out to chocolate, vanilla, and strawberry. And that's it. We're done on that. Okay, test tomorrow. Woohoo!